What is the major product obtained upon addition of Br2 to R-tertiary butyl cyclohexene? Let's first draw the structure of R-tertiary butyl 4-tertiary butyl cyclohexene. Okay, so this is carbon 1, 2, 3, 4, and this is going to have the R configuration, and we do have the hydrogen here. Now, if you imagine that it's going to react with bromine, if we do the bromination, what's going to happen is it's going to form the cyclic bromonium ion intermediate. That's going to look like this, right? But which side is the cyclic bromonium ion intermediate going to be formed? It's definitely going to get formed in the side that's opposite to that of this tertiary butyl group. So this tertiary butyl group is facing toward us, and therefore the cyclic bromonium ion is going to be formed in the opposite side. Okay, so let's draw the structure. And then in the next step, the Br minus is going to act as a nucleophile. Now, since this cyclic bromonium ion intermediate is actually facing in the opposite direction with respect to this tertiary butyl group, this Br minus will need to come in the opposite direction with respect to this cyclic bromonium ion. So technically, it should come exactly in the same direction as that of our tertiary butyl group. So both this bond right here and as well as this newly formed Br minus is going to be coming and attacking in the same direction. Okay, so let's do this. And now we also needed to identify why it should be this carbon, because this carbon has lots of steric hindrance, especially with this tertiary butyl group. So this carbon has more preference for it to be attacked. Okay, so let's do this. It's going to go and attack here, and it's going to push those electrons onto Br. So then if it's going to do that, then this is how it's going to look like. We'll be having the Br. I purposefully put this Br here so you will not get confused with the direction when we count the, when we apply this Cornell-Gold-Prolog system of nomenclature. And then here, the Br will be the opposite direction or facing away from us, and the hydrogen will be pointing toward us. Okay, now let's identify the configuration here. So this is R. There's no change in the configuration on this carbon. Okay, only the there are two new chiral centers that are created, and we needed to identify the configurations of both of these carbons. Okay, let's do the configuration here. So on this first carbon, so bromine is going to be 1, and this group right here is going to be 2, right? And this is 3. And then it's going in the counterclockwise direction, and with the hydrogen pointing away from us, that should be S. Let's do the next carbon. Let's do for carbon 2. So this is 1, and this has to be number 2. This bond right here, whatever is the group, that's going to be number 2, and this is going to be 3. Okay, and it is going in the counterclockwise direction again, but here the high priority group is on the dashed wedge, and therefore we have to reverse the configuration, and therefore this is going to be R. Okay, so when we put this together, so we have one S configuration at, we have the S configuration at first carbon, and then R configuration at the second carbon. And therefore the N, and there is nothing happening here, so that should remain as 4R. So that's going to be the configurations here. To name this to name this compound completely, it's going to be, so if we keep the numbering here, 1, 2, 3, 4, we have bromine at position 1 and as well as 2, so that's going to be dibromo. So 1 comma, we'll put this in parenthesis, and that's going to be 1 comma 2 dibromo. And nothing has changed in this section, so that's going to be still 4-tertiary butyl. And now we have did the addition reaction and we don't see the double bond anymore, so that's going to be cyclohexane.